Okay. Yeah. Okay, so welcome again, everyone. Before we go into the main session, I would just like to do a brief overview of what we do, our women coding community, and how we can help us to grow the community. So first and foremost, we are a new community founded by the leadership team of the former Women Who Code London network. And our mission is to build a safe environment for people, for women to thrive in tech, and also empower them to be at the forefront of technology and innovation. In line with this vision, with this mission, our vision essentially is to empower women through their tech careers, mentorship programs, education, and community building as well. Some of the ways we do this is we provide workshops and events like this one. We also try to connect our members with industry leading experts through our mentorship program. And overall, we try to foster a supportive community where everyone can feel welcome and included. Um, as our way of trying to ensure that we provide like a safe space. We have our code of conduct that guides all that we do and also helps us to safeguard the community. So if you'd like to learn more about that, you can read the full code of conduct, which is accessible at womencodingcommunity.com/code of conduct. And now on to some of the programs that we run. We have quite a number of programs and projects running. First of all, if you are not part of the community yet, you can scan this QR code to join our Slack. I would also be sharing a couple of links after I finish the introduction as well, so that you can use to join. But again, while I'm sharing some of this project, you can also scan this QR code and join us on Slack. So some of the programs to some of our mentors, either for long-running relationships that runs throughout the year or for one-time sessions. Then we also have our open source project, which is basically our way to encourage community members to get started with contributing to open source. Then we have our several clubs, book clubs, writing club, and our CV clinic, which is where you can go to have people try to like review your CV in case you're looking for a job. So again, all of these projects, we have them running in the community. So please do scan the QR code to join our Slack. We also have other projects as well. So mock interviews, study groups, and then we have our different tech tracks, particularly the cloud tech track, which I am a lead of, and which is also related to this today's talk. So if you'd like to again contribute or be part of this project, do join our Slack, and you can also join like the respective channels. When you join those channels, you'd get like you'll be able to see a channel overview, so you can learn more about what those projects are about and how they run when you join our Slack. So again, please do scan the QR code to join our Slack if you're not already there. And now on to volunteers. So because we're a new community, we are always looking for volunteers. Volunteers are always welcome. If you are interested, the first step would be to again join our Slack, and then you can scan this QR code where you can fill out a form that would basically allow you to share your interest with us, the areas you like to contribute, and we can move on from there. So different opportunities are currently available. You can help us to organize events like this one. You can also decide to give a tech talk like this one or other topics. You can contribute to open source, like I mentioned earlier, community blog. Several of our programs that are running, there are opportunities that you can volunteer and get involved in. And then what are some of the benefits, apart from the fact that you get to be a part of like a friendly community that is inclusive, and you are able to like feel welcome in that community. You also get to build your personal skills, so leadership, collaboration, communication. I personally, I also grew from being a volunteer to a lead role, so I would definitely say it's also a nice addition to your CV as well. and then you also get to build these personal soft skills. So again, please, if you are interested or you would love to like help in any way to grow the community, do scan this QR code. I would also share the link in the chat, but yeah, do join us and volunteer for the community. So yeah, again, please do scan this QR code to join our Slack. I'll share the link in the chat and join us to progress our mission. Yeah, so that's all I have for the intro. And now I will be introducing our speaker. Madhura is an engineering manager at Paythru, and she's also one of our amazing leads here at Women Coding Committee. She will be speaking today about function as a service, serverless computing, and giving an introduction session on AWS Lambda. So again, I'm personally looking forward to this session because it's like it's a topic I'm quite interested in. So if you have any questions during our presentation, please do share them in the chat and we'll address them as we go along. But yeah, over to you, Madhura. I'll stop sharing now.
Thank you so much, Myra. Thank you. That was a good presentation and an introduction. Let me start with sharing my screen. Just 1 second. Can you see my screen?
Yes, we can.
All right. Okay, that's cool. So, all right. Today, first of all, welcome everyone. And today we are going to talk about the function as a service and AWS Lambda. I'm Madhura and I'm engineering manager at Paythru. So that's just a brief introduction. So let's see what key topics we are going to cover today. So before we start addressing what is function as a service or what AWS Lambda is, I think we need to understand what is serverless computing first of all. So the first thing I'm going to discuss is serverless computing. Then we'll talk about function as a service. Then the next topic would be covering AWS Lambdas, what are the invocation models, how the execution environment is, how do we manage the Lambda functions, and what are the best practices. So here I'm just going to talk about, this is an introductory section. So some of you I can see that have used Lambda sometime back recently. Some of you have never used Lambda. So what I'm going to do is talk at a very basic level. So everyone is on the same level after this introductory talk. And then we are going to have 2 more sessions, which will be about hands-on training and so on and so forth. So let's start with serverless computing. Just bear with me. Next slide. So let's start with serverless computing. So if you remember, I don't know how many of you remember before 2000, we used to have all the installations were in-house or on-premises. What that means is the organization would have the entire server or the installation on its premises. So when you have this setup, you as an organization are responsible for application, the data, what operating system you're running on, the virtualization, the servers, network, everything. So this was where we were before 2000. Then came cloud computing. So the basic premise of cloud computing, which you may have heard a lot of times people say, oh, we have moved from on-prem to cloud computing. So this is what it means. Cloud computing is where the cloud provider gives you the basic infrastructure, like the servers, they manage the storage, they manage the network. But you, when you're hosting your application, you are responsible for the application, the data, the middleware, and the operating system. A good example would be if you're hosting your application on EC2 instance. In this talk, I'm just going to refer mostly to AWS technologies because that's what I work on. But you can draw parallels with Google and Microsoft as well. So in this case, when you're hosting on cloud, you as an organization are responsible for what operating system the application is running on, or anything which is above this particular infrastructure layer you are responsible for. So that's about cloud computing. So the next advancement was the serverless computing. So in case of serverless computing, what happens is that the infrastructure is provided by the cloud provider, and along with that, there are managed services that are provided. So you as an organization is responsible for application and data only, which is your own, and the rest of the things are managed by the cloud provider. So serverless as such is sort of a misnomer. It doesn't mean that there are no servers involved. It only means that who is managing the servers. So in case of serverless, the cloud provider is managing the servers. So that is what serverless computing is all about. So if I go to the next slide. So what are the technical criteria that define serverless architecture? So there is no infrastructure provisioning, which means that the cloud provider is actually managing the infrastructure for you. You are not responsible for the servers or what operating system it is running. All that is managed by the cloud provider. Automatic scaling. It's whenever you suppose you are getting lots of requests suddenly, if you are managing your own servers, you have to account for the capacity. You have to do horizontal scaling or vertical scaling depending on what the need is. But in case of serverless computing, the cloud provider automatically scales the infrastructure, in which case you don't have to do anything about it. The next is pay for value. You are going to pay only for the execution time or the amount of resources you are going to use. You're not going to pay just because you have booked an instance of a server. So that is, you're paying for only the compute time or the value that you're getting out of the serverless computing. Highly available and secure. So now this again is no longer your headache. It's not our uptime, as they call it, which means that it's basically the cloud provider is going to manage everything on their own, and they are going to make sure that the system is highly available and secure. So you don't have to worry about it. So I think Leslie has commented that it's the server management is done by the cloud provider. So the next one, that what we need to understand, can I take the questions at the end?
Yeah.
Ira?
Yeah.
Or should I just address them right now? I don't mind either.
I think you can also address them as we go along. So Vivian has asked if you could please elaborate on horizontal and vertical scaling.
So basically what happens, there are two options. Whenever, suppose you have an application running and the incoming requests are increasing. At that point, you have two options, either to scale horizontally or vertically. What that means is you can either add more servers. Say, let's say you're running a containerized application and you have 2 or 3 containers up. At that point, horizontal scaling would mean that you add more containers. So you go from 3 containers to say 6 containers to take care of the incoming requests. Whereas vertical scaling is when you add some memory or you increase the CPU, you make the instance larger. That is vertical scaling. So does that answer your question? Okay, thanks.
Yes.
All right. So let's move on and understand a little more about serverless computing. So serverless computing, when I say, it is not just the function as a service. So that is something which, sort of gets muddled up most of the time. So serverless computing is much more than actually just a function as a service. So in this case, for instance, your API gateway, which is provided to you by the cloud provider, in that case, it is also serverless computing. Or for instance, if you're looking at the queue service, in terms of AWS, it is the SQS. That is again a serverless computing. So anywhere where the managed service is provided by the cloud provider and you don't have to manage the infrastructure or its auto scaling, all those come under the serverless computing umbrella. So, as I said, so functional service is just part of it. Yes.
Yeah. Denise as Afsha has an interesting question. She says, "Is serverless similar to platform as a service?"
Sorry, I meant actually not platform, but software as a service. I wrote platform, but I meant software. So
okay.
I think software as a service is something which is you're hosting the software and providing it as a service, right? Somebody is going to use your application. In this case, we are talking about the infrastructure itself. So you're not, it's more about, so if I go back to my first slide, just one second, let me just quickly go. So in this case, if you look at it, this one, which is in white, I think I can use a laser pointer maybe. So in this case, in this, which is white in color, this one is provided by the cloud provider and your application is sitting in here. Whereas when you say software as a service, it is your application, which is the service that you're providing to somebody.
Okay, I got it. So it's in between SAS and PAS, I think.
I don't know if there is a
I think, I mean, in between means it's application as a service. If it's provided, that means it's software as a service.
So yeah, that is for sure. And this one is more of the infrastructure that is being provided. And then, you're not managing that particular aspect of it. So you're going to host your applications. So as we go forward, it might clarify it further actually.
Yes, I think it's clear already. Thank you.
Okay. All right. So let's go to the next slide and try to understand what is function as a service actually means. So here what I've done is, this is actually one line definition, but I've broken up into 4 parts so that it becomes a little more clear. So function as a service is, first of all, it's cloud computing model to allow the developers to execute code in response to the events without managing the underlying infrastructure. So these 4 bits actually form the premise of function as a service. So in this case, if you look at the key points, one is function you write. So you have written some piece of code. So normally I'm guessing everybody knows here what is a function. Function is a small piece of code that you have written. So that is your function sitting on the managed service. So the key points are function you write. It is event driven. So something has happened which has triggered this function, which is going to trigger this function. So let's take an example where, say you are uploading a file to S3 bucket. Now you want to do some processing on this file, say generate a thumbnail image, or you want to generate a PDF out of that file. So what will happen is you upload the image or the file to S3 bucket. It will trigger an event which will sort of tell AWS Lambda that, okay, fine, this now new function has to be run, and then that function would be run and your file will get processed. So that is something which is an event-driven execution. So these are the 2 main bits, and the rest 4 of them, if you see, no infrastructure provisioning, automatic scaling, paper execution, and high availability and security. These 4 bits relate to the slide that we just saw for serverless computing. So as I was saying before, function as a service is part of serverless computing with the additional fact that function you write and it's event driven. So I hope that makes it a little more clear as to what is function as a service. And AWS provides you AWS Lambda as a managed service which is for function as a service. If you look at Google, then Google has something similar, which is Google Cloud Functions, and Microsoft has got Microsoft Azure Functions. So those are the function as a service provided by these different cloud providers. So let's just understand a little more about AWS Lambda. So this is how the not the structure, but at least this is how you can visualize where AWS Lambda is and where your function is. So this is a diagram which shows that, okay, we have an API gateway. This is the managed service, which is the AWS Lambda provided by Microsoft, not Microsoft, by AWS. And this is the DynamoDB on outside. But this is the function that is going to sit within the AWS Lambda, and that is the function that will be executed. So this is the serverless computing service provided by AWS. You write your own function, which can be in one of the supported languages. AWS Lambda supports multiple languages like Python, Java, Go, Node.js. And once you have written the code, you would deploy it to AWS Lambda, and then AWS Lambda would execute it depending on whenever it gets the trigger. So this is how you can sort of visualize what is happening. If I go to the next slide. So far what we have covered is there is serverless computing as the complete umbrella. Then under it, there is function as a service, wherein AWS Lambda is one aspect of it. And then within that AWS Lambda is where your Lambda function or your code is going to execute. I hope that's clear so far. I can't see anybody's faces, so I'm assuming yes.
Yeah.
Very clear. Thank you.
Okay. All right. So let's go to the next slide. Now, some of you may already know this answer to this question, but some of you might be new. So I'm just covering the basics as well. So where can I find my AWS Lambda? So what you need to do is you need to create an account with AWS. And once you have the account, you log into the account, find the service called Lambda, click on it, and you should be taken to the Lambda dashboard. So you will see something like this where you may not have any functions because you have just created the account. So the next question that comes in is, how do I create a Lambda function? So there are three ways of creating a new Lambda function. So one is you use the AWS console itself. So if I go back to my slide, if you click on this create function, you should see something like this here, which is you can create a function using the wizard itself that they have provided. So you put in your function name, click some buttons, and you'll come to the code editor. So that's how you can create. That's one way of creating it. The second one is where you write your source code in one of your IDEs that you prefer, like VS Code or something. You create a build, you package that zip file, and then you upload it to AWS Lambda using the console again. And the third way is you create the zip file, put it in an S3 bucket, and run a CLI command. Now, at this point, you might be wondering, which method should I be using? So the simple answer would be, if you're just writing a test code or you want to quickly test something, just use the console, create a function, and it's ready to go. If you are going to deploy your Lambda into production and you want version control on it, there are many dependencies, or you're calling some libraries, in that case, a packaged file is much better, and you can just upload it. Whether you use CLI or you upload it through the console, it doesn't really matter. It's your convenience at that point. So this is how you would create function and deploy it into AWS Lambda. So that's that. The next is, how is the Lambda function invoked? Now, once you have written your Lambda function, the things to remember here is you would have an entry point into your Lambda function. And this is something similar with, I think, main function that you write, either in Java or Python. So that's something which is the entry point at this point in this. So you write your function with an entry point. So once you have defined your function, let's see how it gets triggered. So there is an incoming request, and API gateway receives the request. So this is your trigger point at this point. So the first thing what is going to happen is it's going to check whether the incoming request or the invoker has permission to invoke your Lambda. And if it does have permission to invoke the Lambda, then it's going to go and try to execute your function. When I say execute, what AWS Lambda does, it will call your entry point at this, whatever you have written is your entry point, that will be called and the function execution will start. In this case, we are just printing the values, and so it will try to execute the function and exit. If you have something like, for instance, you are writing to DynamoDB database, or you are writing to S3 bucket, or something which is your Lambda function is using another service, then it's going to check whether you have rights or not to execute that particular function. So this is just a simple flow. There is more to it, but I'm not going to go too much into detail because this is an introductory section and we have to cover a little more. So this is how your Lambda will get executed. So going to the next slide. So at this point, we have seen that a trigger comes in. We check whether we have permission to invoke the function. Let's say we have permissions. So what happens when actually the Lambda function is invoked? So there are three actual phases before your function gets executed. So the first phase is the init phase. So in the init phase, what happens is the dependencies are initialized. Then it will bootstrap the runtime because it has to download the code, and it does some sort of bringing up the runtime environment, and then it will run the static code which is there in your function. Once the init phase is complete, that means the runtime is ready. At that point, the invoke phase will come in. Invoke phase is where the entry point of your function will be called. Once the entry point is called, your function will be executed. Let's say your function just prints out the values, it will complete, and the execution will end. Once that is done, it initiates the shutdown phase. The shutdown phase is where the runtime environment is shut down, there's dependencies, alerts are sent to the dependencies, and the environment is removed. There is a little more something involved between the invoke and the shutdown phase where it tries to see, does it need another invocation? But for now, you can just think of it as, okay, when Lambda function is invoked, we have three phases: init, invoke, and shutdown. So these three phases are important because the next thing which we need to worry about is the cold start and the warm start. These are the two concepts, which is the cold start means that every time your Lambda function is going to be invoked, we are going to create a new execution environment. And what the consequence of this is, it adds latency to the execution. So if you're expecting your Lambda to, if your request comes in, a trigger comes in, and if you expect that the Lambda is instantaneously run, that is not going to happen. There is going to be a slight delay. Because it's a cold start, it will try to create the execution environment. If it is a warm start, which means that the Lambda retains the environment, then it is a little faster, but it does cost you money. So that's the difference between the cold start and the warm start. If you are just getting started with Lambda I don't think you need to worry about it. These sort of questions would come up in production environment when you're dealing with large volumes of data or requests. So this is just information at this point. The next slide. This is how, let's just try to understand the invocation models, because so far we have said that Lambda is always triggered by events. What does that mean? What sort of invocations are available to us? So let's just try to understand that. And there is synchronous invocation. Now, I think most of you might be aware of synchronous invocation, but I'm just going to cover it in this as well. So synchronous invocation means the calling party is going to wait for the response, which means if I get a request in to my API gateway, the API gateway is going to invoke the Lambda. The Lambda will do something, like for instance, fetch values from the database, and then it would return the response back to the API gateway. At this point, the API, it's a synchronous call. The next one is when we have a synchronous invocation. Here in this case, it's similar to the pub/sub model that I think it's there in Google. So it's something like I have a notification service. I have published some notification. With my AWS Lambda is going to listen on to for some topic, and it's just going to pull it and execute that particular event. The third one is where polling happens. So in this case, some application is going to write to SQS, which is the queue service, and the events are going to get queued up here. And the AWS Lambda is going to listen into the queue and fetch the events and process them. So these are the three types of invocation that we have for AWS Lambda. And each of them have a slightly different behavior. Like for instance, there are retries supported. I think the synchronous one doesn't support retries. So those kind of differences are there. But this is just a general understanding of what the invocation models look like. So having said that, let's look at how do we configure the Lambda. So now, let's say you have written a Lambda function, and before you sort of deploy and start running the Lambda function, there are certain parameters that you need to be aware of, and which will have an impact on your Lambda function. So the three parameters that are configurable and supported by given to you by Lambda, AWS Lambda, are memory, timeout, and concurrency. So there is a maximum limit of 10 GB, timeout is 15 minutes, and concurrency 1,000. So again, these numbers are quite large and will not impact you if you're just writing a test Lambda. But these are something which you need to bear in mind when you're configuring the Lambda functions. So for instance, in this case, your Lambda is going to stop processing after 15 minutes. That's the maximum timeout. You could set a timeout of 1 minute. I think the default is 3 minutes, if I'm not wrong. So you can go as low as 1 minute or as high as 15 minutes. Similarly, with memory, I think the minimum is 128, and it can go to 10 GB. So the reason to be aware of these settings is because your charges are proportional to the memory and the function execution time. So if I'm going to set high memory, I'm going to be charged proportionally. So all these sort of come into picture when you are deploying a Lambda for your production environment. Otherwise, your free tier should take care of it. So here is some of the, here's an example of pricing that actually is used. So in this case, so let's say we have allocated a memory of 512, and the number of invocations we have seen is 20,000. And the duration for which our Lambda runs is 1 second. In that case, this is how you don't have to worry about this. It's just for as an example, I'm showing it. So the amount of allocated memory is say 0.5 GB, then it will do some calculations. AWS Lambda provides you with a calculator, and you can punch in some numbers and see how much it will charge you. But the main thing to remember is they give you 1 million free requests per month and 400,000 GB per second. So if you're just playing around with Lambda, I don't think anyone will reach that limit. So don't worry too much about the pricing, but it's something to be aware of if you really start working seriously with Lambdas. So that's for so far about pricing. Any questions till now?
None so far, but
Okay.
if there are any questions, I think we can take them at the end of the session as well.
Okay, that's fine. So I'll continue then. So the next one that we are going to look at is the monitoring and logging. So at the Lambda itself provides built-in code monitoring and logging via the AWS CloudWatch. I'm guessing you would have at least seen AWS CloudWatch if you are working with AWS. And it automatically logs in your metrics to the AWS CloudWatch. So this comes in handy in case you want to sort of debug or understand what is happening with your Lambda. And the best thing to do is write as many logs as possible, because it's not easy to debug the Lambda functions. Or it's good to have logs and monitor these logs, because one thing that can happen is at some point, if you have configured something incorrectly in your Lambda and you're not aware of it, you're going to rake up some bill. But again, don't worry about it. If you're just doing testing, you will not reach the maximum limit. But these are some of the monitoring tools that you have when you're working with AWS Lambda. The next one, which I just want to specify here, is the environment variables. So far what we have seen is anytime you have written a function, you have to deploy the code, and then that comes into effect and then it gets executed. But what if I don't want to keep changing a single parameter every time? Let's say, for instance, I want to test my Lambda against a test database and then change it to production database. So every time I want to change, let's say we have a constant called DB host. At that point, I don't want to change and deploy the code every time. So one option that we have is to use environment variables. So we can adjust the behavior of our function without updating the code. And environment variables are stored as key value pairs. It's a good idea to do validation on them before using. AWS supports encryption for security. So this is something which comes in handy when you want to actually change the behavior of the function without actually deploying the code. So this is something which is you should try using when you want to try out different aspects of AWS Lambda. The next one which we're going to look at is versioning. One of the potential challenges of Lambda is anytime you write a code and you deploy, it immediately goes live. So it is all, immediately it's deployed and it's available for use. So if, for instance, you want to write a beta function or a beta version, which you just want to test, in that case, versioning is quite helpful. Let's say, for instance, we get a request for V1 resource. In that case, we can direct it to V1, the Lambda function, the version V1, whereas V2 can be directed to our latest one. So this is, again, similar to what API versioning that we normally do. You would have your backwards compatibility, you would have versioning. So this comes really handy only because the minute you deploy a Lambda, it is available for live. So to prevent that or to control the deployment, versioning comes in handy. it does, AWS Lambda even gives you aliases. I haven't used aliases, to be honest, but something you can try it out. Version numbers are never reused, which is obvious, but I've stated it. Then unpublished version becomes the latest new code. So this is just a brief thing about how you would manage multiple versions of Lambda. So after that, what are the best practices? So so far we have covered what is actually serverless computing, and Lambda falls under serverless computing. In this case, the main focus is on the business logic or the application, which is your application that you're writing. So whenever you're writing an Lambda function, make sure you keep the business logic separate, write modular functions, keep the functions stateless. Now, this is quite important because between the invocations, your state is not going to be carried forward. So you have, for horizontal scaling, it is quite important that the functions are stateless. If you need states, I think you need to put it in Redis or some sort of an outside service. So minimize the size of your deployment package. I don't think you will have any issues anytime, because I think maximum package supported is 50 MB, if I'm not wrong. So, but again, it takes time to upload the package and deploy the code. So it's good idea to minimize the size of the deployment. Include logging statements. As I said, you will thank yourself later, because it's very convenient if you already have logging statements and you can debug something. Use environmental variables where possible, because that will mean that you are avoiding deploying your code every now and then. Avoid recursion, because there is a hard limit of 15 minutes or whatever timeout you have set. The Lambda is going to time out. Return response codes, again, is similar to what we do with APIs. It just is helpful. So the next one I have is the resources. AWS Lambda has got good resources, and you can learn quite a lot from them. There is a serverless application, a tutorial which you can visit and try it out. There are a couple of books which I have mentioned here, which is worth reading, and if you want to pursue it more. And I think that's about it. That's the last slide I have. So thanks for listening. And if you have any questions.
Thank you very much for that. That was a fully packed session. And yeah, we do have questions. I personally have questions, but first off, Leslie is asking, what does a modular function mean?
Modular just means that you it's a good question. Modular, I mean, in my head, I know what is modular, but something which is reusable, or, it doesn't have too many dependencies on the other functions. So the code is modular when it's self-contained, if that makes sense. So you can reuse a piece of code if it's modular. Does that make sense, Leslie?
Yeah, yes,
Okay.
it does. Thank you for that. And then another question from me. When you say stateless, you keep your Lambda function stateless. What do you mean by that? And if you could share maybe like a very simple example of what a Lambda function that is stateless should look like or should be.
So normally, if you have some sort of, say, a web application, right? In that, what will happen is generally you will have some session variables or something where you say you're making a request to your application. You want to know that, this user made this request. So you will have a session or a state maintained in your application, so that the next time the request comes in, okay, this is the user. And so that sort of an interaction is there, right? So you're maintaining a state. It could be like, for instance, I'm trying to think an example. It's a simple example, like, if user reference, you are making a user is going to make a request. Somebody's asking something. So a state is an action like pressing. No, state is something you maintain on the server, like a session variable. Or yeah, sticky session is the right one, where you actually have a session maintained within your code. So within your function. So in that case, like for instance, I'm trying to think of an example here. It's how if session variables, I'm trying to think.
Dennis has mentioned something about maybe you want to keep
Yeah,
the
user
user
is
logged
logged in. User is logged in is a good example, because you know that the session for that user is maintained. In which case your function, if you're writing a function, you can't have a user logged in kind of a session, right? You can't maintain, because your function is going to be executed and it's going to exit. And we saw that there are phases, right? Init phase, invoke phase, and shutdown. The function, the whole Lambda is going to shut down the execution environment. So once the environment is shut down, the next invocation will not have that session state, which you were maintaining in the previous one. So the function should be stateless. If you need some sort of, session or some sort of state, you need to put it outside, which would be probably, I don't know, some Redis, Memcache kind of, or DynamoDB, which sits outside, but it can't be within the function.
Yeah, thank you very much. I think that's like a good way to look at it, because when you're trying to consider what part of your code could go into like a Lambda function that you want to be able to like invoke, like you want to ensure that like you are not putting functions or parts of your code that need something like a state or like a session. Like
exactly. So it can't have that. Like, for instance, if you have something like cookies or something, you can't maintain it because your environment is going to shut down. And I think someone has mentioned step functions.
Yeah, thank you for that. But there is another question. Lambda functions have a max timeout of 15 minutes. How and what can be used if the code needs more time to process, like 25 to 30 minutes?
I think it's a hard limit of 15 minutes. I don't think it goes beyond that. You might have to probably rethink what you can do within the 15 minutes and probably sort of have another function do the rest of it. But it can't be linked. You can't have one. Maybe step functions is another thing, but I haven't used step functions anytime. So, but definitely there is a hard limit of 15 minutes. I don't think you can increase that 15 minutes to 25.
To follow up your question, Prabha, Leslie has mentioned that she uses step functions too. So if you have like longer processes that exceed that limit that Lambda has, then I guess you can use step functions like she has mentioned.
Yeah, I think Leslie is a good candidate to answer that question because she uses, she is my mentee actually. And I know she uses Lambda and step functions quite a lot at her work.
Thank you. Okay, so we have two more questions, or a few more questions, because I do have questions as well. How does AWS Lambda manage incoming traffic, which may cause multiple new environments to be created and may consume the predefined memory?
I think it would be the concurrency that would dictate how many lambdas are spun at the same time. And that is where I was saying, right, there are three parameters that you can configure. One is the memory, one is the timeout, and then there is the concurrency. So you can have just one lambda actually picking up the events. Prabha, you were saying something?
No, sorry, I was just unmuting. Sorry.
Oh, no worries. Okay. So yeah, so that I think it would depend. If that is your question, Vivian, think it matters what sort of concurrency setting you have.
Okay. Vivian, if that answers your question. Okay, great. One more. Now asks, can you explain the difference between asynchronous and polling invocation models again?
Yeah, okay. Asynchronous is something where, let's say, for instance, if you're familiar with the PubSub model, or the publisher subscriber model, where somebody is going to publish an event, and the subscriber just consumes it, and the event gets processed. That is one example of asynchronous event. Or it could even be in case of an API response. What can happen is you're making a call to some endpoint, and the endpoint just quickly returns, okay, fine, I will process your request. And then later on, once whatever the response you want is ready, you either can get a call back or something. That is asynchronous processing. Whereas polling is where actually the AWS Lambda is going to keep checking on the queue, saying that, do I have any events to process? Do I have any events to process? And once it has events to process, it will take the event and process it. So one is asynchronous, where you just send something, it gets processed, and eventually you will come to know what happened. And the polling is where you are actively, the Lambda will ask, okay, do I have something to process? So that's the difference between the two. Does that help, Selena?
Yeah, great. Thank you.
Thank you.
And then I do have like some general questions. So say for example, with serverless and AWS Lambda, you are looking to incorporate or start using AWS Lambda, and you have say like a traditional API that is like as like a monolith sort of architecture. How can you incorporate, or how can you get started with using or extracting out some functions that you can run with Lambda? Or how do you go about it essentially if you're trying to, or you're a backend developer and you have like an API and you're trying to, leverage Lambda functions to run some things?
It actually, it is a good question. Like, for instance, you have a monolith application and you want to slowly move away from it and make it serverless. So I think at that point, the main things to remember is just going back to the fundamentals of what the Lambda is, right? You have 15 minutes of processing time. Now, at that point, definitely 15 minutes is a large amount of time, but it has to incorporate some business logic that, you can actually have that processing. So let's say, for instance, you want to process a file and generate PDF out of it, because you are running some sort of a billing organization, where right now in your organization, you have a big application which generates invoices, PDF invoices, and it's a quite cron jobs run every night or something, and that PDFs are generated. In this case, what you can do is you can actually sort of split that portion of code which is going to generate the PDFs, right? And that can become your Lambda function. And whenever, say, you upload a file or your whatever the billing information onto a S3 bucket, it can trigger that Lambda and generate a PDF invoice and then send it to the client or something. So you need to start looking at it from those point of view, where is there something independent in my monolith architecture that I can just move it to Lambda and slowly start chipping it off. So that, I think, is quite possible, and it may take you time if your monolith is very big, but you can start looking at, like, for instance, if your application is logs something, right? Everybody has a logging mechanism. Now, at that point, if you're logging every time you're writing something to CloudWatch or something somewhere, maybe that logging application or emailing everybody sends emails. Can that move to a Lambda where something, it needs to be sort of a standalone everybody can use. So that's how you slowly start chipping off, your monolith and start making it a little more leaner.
Thank you very much for that, because I try to I'm getting more into backend, and I'm trying to sort of see how I can also leverage like serverless services, and it just sort of feels like, oh, where do I start from? How do I like even start essentially? So I think also the resources that you shared, it would also be good to have like those links. So if anyone is new and wants to get started with they will be able to also like be able to have access to those resources. Yeah, thank you very much. We are running like a little over time, but does anyone have any other questions before we wrap up? I would like to also share one sec, because I also want us to fill our form. Thank you for attending this session, Vivian. I am glad that you were able to learn a lot, because I did learn a lot myself as well.
Stop
Yeah,
sharing.
so
Sorry.
okay. Yeah, so let me just share this. So yeah, thank you again for attending the session. Please do take some time to fill out our form. This would allow us to also improve future sessions, and we'll also get to know more about like what you're interested in learning, so we can get more speakers to come up and have those tech talks with us. I would also share this link in the chat now, and also it will also be on our Slack channel. So again, if you've not joined our Slack channel yet, or our Slack community yet, please do use the link to join before we end the session as well. One sec, I'm trying to share the link. Okay. I think I'll just share that as I'll share that later in our Slack channel. So please do join. And if anyone does not have any questions, I think we can close out the session.
Thank you so much. Thank you everyone for listening. You have been just great. Thank you so much.
Thank you.
Thanks, Ira, for being there for me. Thank you so much.